All right, so I'm going to kind of go quick through it because I know you've already seen this, but please ask questions like on anything you were unsure about. This is synthetic and long division, okay? Both methods to use division. Long division can be done every time. Synthetic can only be used if it's an x plus or minus a number. So if you have something that's divided by x squared, it has to be long division, okay? If there's a number in front of the x, it can be done using synthetic, but it involves fractions, multiplying and adding, and people tend to screw that up. So really, you just want to look for the x plus or minus. That means synthetic, and then anything else would be long division. So these are the steps of long division. This is a long slide. It's long division, right? So the first thing for both synthetic and long division is to arrange the terms of both the dividend and divisor in descending powers of the variable. And if there's any term missing, you're going to fill it in with 0x followed by whatever the power needs to be. So if I had an x to the third and an x, I'm going to fill in 0x squared. Then you just divide first into first, multiply out the rest, change the signs and add, and then bring down the next term and repeat that process until the remainder can no longer be divided, or the degree on the remainder is less than the degree of the divisor, the thing on the outside. And then we write our answers as quotient plus remainder over divisor. So we write it as a sum. So like number 1, this is in order of decreasing degree. There's no terms missing. So I would do x squared minus x minus 2, and then x plus 1 goes on the outside. I divide first into first, which would be x, and I multiply that by both the terms on the outside. So x squared plus x. Instead of subtracting, I recommend changing your signs and adding. Seems that people make less mistakes then. So if I change my signs and I add, these cancel, I get negative 2x, and then I bring down the minus 2, and I do the same process over again. First into first would be negative 2. Multiply that by both on the outside, negative 2x minus 2. Change your signs and add, and my remainder is 0 here. So the quotient is just x minus 2. Good on that one. Yeah. Okay, the next one, again, in decreasing degree order. Okay, divide first into first, and it's x again. Multiply on the outside, x squared plus 3x. Change your signs. These cancel, negative 4x. Bring down the minus 2. And then this would be negative 4. Repeat that process. Change your signs. And this time we get a remainder. So I would write this as x minus 4 plus 10 over x plus 3. Everybody's good on that one, right? Yeah? Okay. All right, so this one, okay, would be the same. There's nothing missing. You would put it in decreasing, it's already in decreasing degree order. The difference is their coefficient on the front. You would just multiply by 5x squared in order to get that. You remember this one worked out? Everybody okay on this one? Yeah? Okay. This is the first one in which your terms are missing. So first of all, they need to be in decreasing degree order, and then you have to make sure there's one for each. This is missing the 0x squared and the 0x. And you could make it positive or negative 0. It doesn't matter because it's 0. It doesn't hold its sign. But don't forget to add those terms in. And then divide by x plus 1. So then on the outside, I'd multiply that by x squared. Goes both times. Change your signs. These cancel. Negative x squared. Bring down the 0x. Multiply by negative x. Change your signs. These cancel. X. Bring down the 1. Minus 1. And it's positive 1. Multiply it out. X plus 1. Change your signs. Cancels. And I get negative 2 for my remainder. So I have x squared minus x plus 1 plus a negative 2 over x plus 1, but we don't leave the negative in the top. We rewrite this as minus 2 over x plus 1. Questions on that one? All right, then came synthetic division. So I know I'm a nerd. I choose to teach math for a living, but I think synthetic division is fun. Okay, because it's fast and it's easy. You eliminate all the variables, right? So we go back to just the coefficients and the constants. The same step is number 1, which is put them in decreasing degree order. Make sure if there's anything missing, you add a 0 in for that missing term. It's a placeholder. Then whatever the divisor is has to be x plus or minus a number. we write the opposite of that on the outside. So if it was x minus 3, positive 3 goes on the outside. If it was x plus 3, negative 3 goes on the outside. You bring down the first term, you multiply the outside by the term on the bottom, and then, you multiply the term on the outside by the one on the bottom, and then you write it in the next column. You add it, and then you repeat that process again until all the columns are full. The last term is the remainder, and then the degree of the first term is 1 less than the degree of the dividend. So you can either go left to right on that or right to left using the last one as the remainder. So same first step, has to be in decreasing degree order. Nothing missing, right? Which it is. So then I take what's in the front of all of these. So it would be 1, negative 2. I draw like that, long, stretch out L, bracket. And the opposite of this goes on the outside. I bring down the 1. I take what's on the outside. I multiply it by what's on the bottom, which would be negative 1, and I put it in the next column. I add those. I multiply again what's on the outside by what's on the bottom. Negative 1 times negative 2 would be a positive 2, and I put that in the next column. And then I add those. So the last thing is the remainder. And then you can go left to right. It would just be 1 less degree than this, which would be x to the first. I like to go right to left. After the remainder, the next one's the constant, and then after that one would be x, and then it would be x squared and x to the third, and so on and so forth. So my quotient is x minus 2. No remainder again.
And how do you know what to use synthetic division?
It can be any time it's x plus or minus something. So it can be x plus 5, x minus 10. It just can't be x squared. And it can be done with a coefficient like 2 at the front, but then negative a half goes on the outside, and you have to multiply and add with fractions, so we tend to make silly mistakes there. Yep. So on the homework it says use long division to do this, and the test would be the same way. It would tell you what to use, or it would get to the point that you could have a choice, and if it's x squared, let's say, plus 1, you can't use synthetic. So it might look like you have a choice, but you really don't. You'd have to use long division. Yep.
How many sections do you have?
It's really, I think we... All right, so this one is, are my exponents in decreasing degree order? Is there anything missing? No. Can I do synthetic? Yes. So my coefficients would be 1, negative 1, and then the constant negative 2. Draw the bar. What goes on the outside? Good. Bring down the 1. Multiply the negative 3 times 1. Put it in the next column. Add it. Multiply the negative 3 times negative 4. Put it in the next column. Add it. That's my remainder. Then the negative 4 is my constant. The 1 gets the x. So it would be x minus 4 plus 10 over x plus 3. Yep.
How would you do it if the denominator was x minus 3?
Then positive 3 would go on the outside. Everything else would be the same. All right, now we've got the one with the coefficients, right? Again, it's in decreasing degree order, so I'm not rearranging anything yet. But this time it's not just 1s and 2s. This is 5, then negative 6, then negative 28, then negative 2. On the outside goes the opposite of what's here, which is negative 2. Bring down the 5, multiply it by negative 2, so it's negative 10. Add it, so it's negative 16. Multiply that out, so it's positive 32. Add it, it's 4. Multiply it out, it's negative 8. Add it, it's negative 10. So here's my remainder. The 4 is constant. The 16 gets x to the first. The 5 gets x squared. So it would be 5x squared minus 16x plus 4 minus 10, because the sign is going to get brought back out front, over x plus 2. Questions on that one? All right, now are there terms missing? Yeah. So I plug in, there would be a 0x squared and a 0x. When I go to do this with long division, if I actually tried to divide it and I didn't remember to put the placeholders in, I would put an x squared up here, I'd multiply it, and I'd get x to the third plus x squared. And these can't be combined. So it's almost like it would stop you, and you'd be like, shoot, I did something wrong. Synthetic, you won't catch it, because synthetic, it's just numbers. So you have to be really careful and make sure that you check for those missing terms. So it would be 1, 0, 0, negative 1, and then on the outside goes the opposite of this, which would be negative 1. I bring down the 1, multiply it times -1, put it in the next column and add it, multiply it, put it in the next column and add it, multiply it, put it in the next column and add it. There's my remainder. The 1 is the constant, the -1 gets the x, the 1 gets the x squared. Minus 2 over x plus 1. Questions on any of those? All right, now again, it's just more complicated. It's still in order. This one's not missing any terms, okay? But can I use synthetic? No. As soon as you see that x squared that you're dividing by, you cannot use synthetic. So I have to set up long division. X squared plus 2x minus 3 goes on the outside, first into first. So this would be 2x squared. I'm going to multiply that times all three terms. 2x to the fourth plus 4x to the third minus 6x squared. Change the signs. Cancels. That cancels as well. Positive x squared, bring down the plus 3. And I have to keep going because there's 3 terms on the outside. I have to bring down the -2 as well. Now, first into first again, and it'd be plus 1. Multiply it out. I'd get x squared plus 2x minus 3. Change my signs. Cancels, and I get x plus 1. Now that whole thing is the remainder, because I can no longer multiply x squared by something to get to x. I mean, I can, but it'd be a negative exponent, which you don't have to do. So my quotient is x squared plus 1, and my remainder is x plus 1 over that whole thing, x squared plus 2x minus 3. So if you're dividing by an x squared, you cannot do synthetic. You have to do long division. Everybody good so far? Yeah? Okay, then comes the application of these things, right? That was just your straight up synthetic division, long division. And then you get applications. So the first one is remainder theorem. And this basically says if I try to evaluate f of x given a value, I could either take that value and plug it in like we've been doing before. Like if I gave you f of x equals x plus 3, and I said find f of 2, you would have taken 2 and just plugged it in, and you would have gotten 5, right? Now this is saying if it's divided, if you actually take what's in the inside and you put it on the outside and you divide synthetically, the remainder is the same thing you would get by plugging it in. So you have the option there. You could go back to evaluate, plug it in, and find the answer, or you could use synthetic division. If the instructions say use synthetic division and the remainder theorem, you have to do it this way. It doesn't mean you can't check it the other way, but you're going to have to do it this way, which is what the instructions will probably say. So for a 10, I'm going to take -2. Now this time I don't change the sign because this is not x minus 2. Then I would change the sign on the outside. This is actually saying x is equal to -2. So the 2 stays negative on the outside. This is in decreasing degree order. I'm not missing any terms. So I start synthetic division. 3, -6, 2, -4, 1, -2, and -9 is the answer. I don't need anything else, just -9. If you took and plugged in -2, you should get the same answer. In cases like this, the new way is faster, right? If it was only a couple terms, it's not that big of a difference, but the new way is faster this time. So then 11, I would put 4 on the outside. Again, not missing any terms, in decreasing degree order. Bring it down. Multiply it out. And just the remainder is the answer. Obviously much easier than having to do 4 cubed times 4, and then 4 squared times 10, and then adding them all together. This time I think it's easier. So you just got to, 1, pay attention to directions if it gives you the option. What may not. It may say use the remainder theorem in synthetic division to do this, and that's what it means. Still good? All right, then comes the factor theorem. And this just basically says that if your remainder is 0, that number or that term is a factor, okay? If you think about it, if I said, like, is 2 a factor of 10, you would tell me yes, and the reason is because if I divide it, it goes in evenly. It's the same concept with expressions, okay? So if whatever you're dividing by, whether it's long division or it's synthetic division, this remainder is 0, then that term is a factor of the initial polynomial. So if you are given a solution, if I give you one solution, you're going to use that answer on the outside of your synthetic division to reduce your polynomial a degree. The remainder should be 0 if you do it correct. And then whatever's left will become, quadratic, and then that you can solve either complete the square, sometimes it's factorable, not usually, but sometimes it's factorable, or fall back on your quadratic formula is probably what I would recommend. So that looks like this. First of all, oh, sorry, not like this yet. This says determine if it's a factor. So how do I know it's a factor? The remainder 0. So what goes on the outside for the first one?
2.
Good. Positive 2 goes on the outside. It's already in decreasing degree order, so it's 2, 7, negative 4, negative 27, negative 18. Bring down the 2. Multiply it, put it in the next column, add it. Multiply it, put it in the next column, add it. Multiply it, put it in the next column, add it. Multiply it, put it in the next column. And my remainder is 0, so this is just yes. Okay, it is a factor. Negative 3 goes on the outside this time. 2, 7, negative 4, negative 27, negative 18. Bring down the 2. Negative 6, 1, negative 3, negative 6. Positive 21, negative 6, positive 18, and 0. So this is also a factor. So here's the thing. If something is a factor of the first thing, it will also be a factor of its reduced polynomial. So if this is the reduced polynomial of this, then I can actually test this on those numbers. I could take negative 3, put it on the outside, and if it goes in evenly, then it is also a factor of the initial one. So you can do that. You can use the factor test after you've already found one. All right, so this is like the big one. This kind of puts it all together. So this says, given that x plus 3 is a factor, find all the factors of the zeros and then use a graphing utility to verify the zeros. So on the outside goes what? Negative 3. This time I'm missing stuff. I'm missing an x squared, so this would be 0x squared. And I would end up with 1, 0, negative 19, and negative 30. Bring down the 1, multiply it, add it, multiply it, add it, multiply it, add it. If this is not 0, you did something wrong. If it blatantly says this is a factor and that's not 0, then something's wrong. So you can always catch it from there. But then I get, this would be x squared minus 3x minus 10. Is that factorable? Yes, right? You saw it happen yesterday. It would be negative 5 and positive 2. And I end up with positive 5 and negative 2. So when it's finding all the factors and the zeros, it's the negative 3 from the first one plus the 5 and the negative 2. So all 3 would be zeros. So if I list zeros, it looks like this. If it wants them written in factors, we put x minus in front of them. It changes the sign. So it'd be x plus 3, x plus 2, and x minus 5. So this would be if it was factors. And if I had time to check my answer, I could FOIL out those 3 and get my question. So if you've got your zeros, you can actually multiply that out and check to make sure that it would match. All right, let's do the graphing calculator part. So if you have it with you, take it out. Remember, you are going to need it for your test. So if you have not been bringing it with you, you definitely want to start, especially for tomorrow's lesson, you're going to need it. All right, so the first thing I'm going to do is, obviously, when you're working with your calculator, you're normally in this state, okay? You're going to go to y equals, and then you're going to type in that function. So x is the x, t, theta button. It looks like this. You're going to hit that. The caret is your exponent to the third minus 19x. Oops, that's not supposed to be in the exponent. Hang on.
Wait, how do you do x to the third?
It's the caret. That little, like, it's underneath the clear button. the caret, and then the 3. And then minus 19x, and then minus 30. Hit enter. And then I go to graph. Kiara.
How do you get the X?
The X is the little button next to the green one that says alpha that says xt theta n. Do you see the green button that says alpha? Let me see yours. Oh, good.
Oh, so it's X split?
No, it should just be X. Okay. You're welcome. Okay, so now when you look at your graph, it should look like this. Okay, you're missing part of your curve. It's happening like way low below where the window is. You can zoom in and out of your graph a lot of different ways. One way is by literally hitting the button that says zoom. And then you can go zoom out, which is 3, hit enter, but you have to hit enter again to get it to actually zoom out. It's still cut off, so if you wanted to see the whole graph, you would zoom out again. That's one way to get it to zoom out. The other way is to look at the window. If you look at the window here, it's already at negative 40 to 40. So normal window is negative 10 on the X, positive 10 on the X max, negative 10 on the Y min, and positive 10 on the Y max. That's like your standard window. That's your square standard window, which usually I would say is fine. Obviously, if I was trying to catch like the minimum here, I'd have to zoom out. If I was trying to catch the y-intercept, I'd have to zoom out. But we're just verifying our factors or our zeros, which is everywhere it crosses the x-axis. So if you look at my x-axis, I have the curve crossing through at negative 3. It crosses through again at negative 2. And then it crosses through again at 5, which matches our zeros that we found. Okay, that's one way to look at it. The other way is if you hit table up here, second graph, get to the table, and all the zeros are when y is 0. So if y is 0 on the right hand side, then I've got 5. If I go up, y is also 0 at negative 2 and at negative 3. Does everybody see that? So you could also see it that way. There's a bunch of different ways. On the next section, we're going to mess with how to find the zeros by like tracing it. We would go to the y equals, we would graph it, and we would hit second, trace, and we'd go to 0. And we would go left and right of each 0. So left here, and then right here, hit enter. It brings me to the intercept right there. I could do that again to the 0. This time I go left of it, the next one, right of the next one, and then I hit enter again. And then if I want to do that last one, second trace, go to the 0 again. This time I got to get closer to that 0, so I got to come all the way over here. Left of it, right of it, and hit 0, and it will bring you to the last one. So by the time test comes around, you're going to want to know how to find a max, how to find a min, how to find a 0, how to find a y-intercept, like all those things, which is really what the next section is all about. You want to start to get more and more comfortable with your graphing utility, okay? If it was something like this where it's just verify, you're literally just checking your answer. But this is this is like, imagine a standardized test in which you have to solve an equation. You could always graph it and find where it crosses the x-axis. It would be the same answer, okay? So in here, you're not going to be able to use your graphing utility all the time. But on a standardized test, you can use that graphing utility for not anything, but all the calculator parts. So it's really good to get to know your graph. Questions on any synthetic, long, or application of them? Anybody start the homework that have questions already? Yeah. Or you just tell me you started homework. That have questions?
Yeah.
Yeah.
Like the second to last one.
All right. So it said, consider the following. Use the 0 or the root feature of the graphing utility to approximate the zeros of the function accurate with 3 decimal places, blah, 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 blah. The first one is the 3, right? So the 3 is the only one that if you actually use the graphing utility, you can find the specific point on your x-axis. The rest of them we're gonna be decimals, okay? So these are actually better answers. Like your answers are better than WebAssign answers because WebAssign is gonna be approximated. If there's a whole number one there, then you can take that and you can put it to the outside and you can use synthetic division to reduce this a degree. So 0. And then I would take this, which is x squared minus 2, set it equal to 0 to find the other 2, which is that how you did it?
So that's how I would do C.
Not yet. Then this would become x squared. Well, this would be x equals plus and minus the square root of 2. So my other 2 zeros are plus and minus 2, and then the 3 is the last one.
Yeah, that's how I found
A, that's how you found the first one, right? Then for C, you would just use that, but it has to be in completely factored form. So you can't leave it as x squared. So it's x plus root 2, x minus root 2, and x minus 3. So you need all the roots after x minus. So change all the signs on them and put them x minus. This, when it says factor completely, you just can't leave it as the squared. It might have even marked that right if you also had x minus 3, but you do want to factor it as much as you can.
Okay, thank you.
You're welcome. Anybody else on the homework? Yeah.
For those, you needed a calculator.
For this one, you needed a calculator. Yeah. So you could. All right. So use synthetic to show that x is the solution. Use the result to factor the polynomial completely, and then list all the real ones. So you're going to take this and you're going to put it on the outside. You're going to take negative 3 to the outside. And then they're all there. They're in decreasing degree order. So 1, 6, 11, 6. Bring this down.
Oh, wait, we don't change the 3?
If it says x equals, you keep it. If it was x minus 3 is a factor, then you change it. Is that what was wrong?
Yeah.
Yeah. So then, because then it wouldn't be 0. So hopefully you can catch it from there. So then that one's factorable.